How many of you like to work with your hands? How many of you are already in school getting trained to be a technician? If you answered yes to either of these questions, you'll want to listen up. We will present a glimpse into the up-and-coming field of integrated photonics. Now, some of you may already be saying, hey, I'm already a technician, but this integrated photonics program will help you specialize in a really important area in manufacturing. We'll describe a unique hands-on learning experience in a program for technicians. It's a technician certificate program, and it's called the Advanced Manufacturing and Integrated Photonics Program, which we nickname AMIP. I'm Cheryl Schnitzer. I'm a chemistry professor at Stonehill College, and I help oversee this program. In the AMIP program, you would take classes on both Stonehill College and Bridgewater State University campuses and participate in a boot camp at MIT. For more information, please visit www.stonehill.edu/photonics. Photonics is a science, practice, and technology of manipulating light. It is based on light waves and photons, which are the fundamental particles that make up light. The 20th century was known for electronics, and I'm sure you're all familiar with the chip, which is the electronic integrated circuit. The 21st century, which is happening right now, is growing with the photonic integrated circuit, in which instead of using electrons, we're now using photons in combination with electrons, which is a very powerful combination. Photonics has a host of applications, and it's increasing daily, from communications, including optical fibers, telecom and datacom, medical applications like laser surgery, endoscopes and sensors, and information processing. Some of you may have heard of big data and analytics, as well as quantum computing. Industrial applications with precision optical measurements, laser cutting and welding, and photolithography. Aviation, military, and public security applications, including gyroscopes and rangefinders, remote detection, and night vision. And finally, for all the Harry Potter fans out there, metamaterials produce light with unusual properties, such as the so-called invisibility cloak. One specific application of photonics is self-driving cars with LiDAR, light detection and ranging for self-driving cars, to help with precision and accuracy.
Hi, I'm Melissa Ratliff, the Dean of Graduate Admission at Stonehill College. The great thing is that the future is bright for photonics. And over the next decade, there'll be significant growth in the field, which is a great thing for job opportunities, especially in the Northeast. Our program is a 15-month program that starts in the summer and consists over 4 semesters. As you can see on the screen, we have foundational courses that allow students to take a deep dive into elements related to an array of manufacturing roles. And then we get into our industry-wide manufacturing content. After that, we take a deeper dive into institute-specific courses that really allow students to learn fundamental areas related to photonic integrated circuits, introduction to fiber optics, and introduction to optics and photonics. We're now accepting applications for our 2021 cohort, which will start in late May. In addition to the courses, students have the ability to take a deep dive and do a capstone project, and the program is capped off with an internship. where you can take all of those skills and pieces of information acquired in the classroom and apply it in a position where you're learning about the field firsthand. I'm now going to hand it over to one of our faculty members so you can take an inside look in the classroom.
Hi, my name is Ed Devaney, and I'm a professor of physics at Bridgewater State University. And I actually use photonics to laser cool and trap atoms. But what you're seeing right now is one of our courses, and this is an electronics course. So just as much as you'll have to understand how to manipulate light and photons on a chip, you'll have to understand how to use electronics on a chip. So this is a course being run right now. You're kind of seeing the actual hands-on application of everything you'll be doing. You'll see that you have to work with oscilloscopes and function generators and multimeters. You'll have to read schematics and electronics. And then you'll have to put the electronic devices together and actually test them. So that's what we're seeing right now. Or this is a class that's actually going on this fall right now. And we'll run through this for a second. This is with Professor Hernandez. And you can see it's much like the workplace. You'll be working with different schematics for things you'll have to design in the workforce or research lab. And then you'll have to implement it and get it to work. It's a blast. This is one of my favorite courses. I love it. And then after you do the electronics, you'll move on to putting the photons and the light on a chip. So there's the instruction board, and we'll follow that up with one other video of a student actually getting some neat results. It's a little hard to hear, but what they're making right here is called an NPN transistor voltage amplifier. You can see the schematic, the wiring. And the yellow signal is the voltage in, and the blue signal is the voltage out. And so what he was able to do was multiply the input voltage by some multiplication factor and get an amplified signal out. But this is the type of thing, it's real equipment, real schematics, real problems that you'll see in industry and in the research lab, and you'll be able to do them. And it's a lot of fun. Thank you. So now maybe I'll hand it over to some of the exciting simulations that we'll be doing.
Thanks, Ed. So one of the exciting things that you'll be able to do as a student in this program is use our interactive simulations. So here is an example of one of our interactive simulations where you get a digital experience working with a fiber lathe for optical fiber manufacturing. So as you can see, you'll be able to explore this digital space and learn the procedural skills in how to manufacture optical fiber, as well as explore more conceptual skills about how the tool works. So these tool training simulations are one of the things that you will explore later on in our program. In addition to tool training simulations, we also have circuit level simulations. So as we were learning previously, we're going to be focusing in this course on integrated photonics and circuit level photonic chips. And you're going to learn about the functioning of these devices on a chip. And in addition to viewing animations, you'll be able to interact with optical circuit components and use interactive simulations in browser to be able to explore these devices. So we are very excited about being able to offer these interactive environments for you to explore.
Well, we hope you enjoyed our quick tour of the AMIP program, and please visit and learn more about our photonics endeavors at stonehill.edu/photonics. Take care, everyone.